Assalamu alaikum and welcome back to Technology Explore. My name is Usman and today in this video I'm going to do some simulations on this weldment model, which is actually chair, and I will do three simulations to calculate its displacement and the factor of safety. So keep watching this video till end. Let's start. This is the model and I want to simulate it by using SolidWorks simulation. So now what we have to do, click on new study here and then select static, press OK button. So one by one we have to or step by step we have to do this simulation. So first step is that we have to define the material for this model. For that, right click on the model name and then select apply material to all bodies, and then select your desired material and then select apply and close. So after adding the material, we have to determine which parts of our weldments model will be simulated. So as you can see, this is not a weldment part, also this is not a weldment part. So what we have to do, we have to exclude all non-weldment parts from our assembly. So for that you can click on these parts, and you will see automatically on the feature manager those parts will be selected. So select, right click on the part and then select exclude from analysis. So one by one you can exclude them from the analysis, or you can also select multiple by press and hold control key and select multiple items. So once you have pure weldment model, then scroll down from here, and first of all you have to define from where your model will be fixed. So right click on the fixture and then select fixed geometry. On the right side, on the left side, you will see these options. So select joint option from here and then select this joint, this joint, this joint and this joint. So our part or our model will be fixed from these four joints. Then press OK button. Now we have to define what is our load. So for that, right click on the external load and then select force. So now in the force option you will also see these options. So from here select beam and then select this beam and this beam. Then scroll down and select the direction by clicking on this box and then select this line. Again scroll down and turn on force. Make it on the reverse direction by checking this box, and then type here the force that you want to add in this model. So for example, if you don't know what is the exact force for your model, you can calculate it by using calculator. Let me show you how. So let's assume if a person who is going to sit on this chair has the weight of 80 kg. So weight is 80 kg, which is multiplied by 9.8, which is gravity. As you know, the formula for the force is mass into acceleration or gravity. So the mass is 80 kg and gravity is 9.8 meters per second square. So we got the exact force 784 or 784 Newton. You can put it here 784 Newton and then press OK button. So we have done all initial conditions of our model. Now we can make the mesh. Right click on the mesh and then select create mesh. So this is the mesh quality. You can adjust it according to your desire. Then press OK button to create the mesh. So here the mesh has been generated. Now we can run this study. So for that, click on this button, run this study. So now if you can see, we are facing this error, model is unstable. How can we resolve this issue? We can resolve this issue very simple, by very simple way. You can right click on the study name here on the top, and then go to properties, and in the properties turn on or check this box automatic solver selection and press OK button. Then recreate the mesh and rerun the study. So mesh is once again generated, and now I'm going to run this study. So our study is now complete. Stress, this is the displacement of our model. And one thing which is very important to know is that, so as you can see, there is a very large displacement in this model. So this is not actual displacement, because when you right click on the displacement and then go to edit definition, so deformation shape, it is by default selected automatic, and in the automatic, if you can see, this is 192 times greater than the actual deformation. So you can turn on the true scale to see the exact or actual displacement in your model. So select true scale and then press OK button. So this would be the actual displacement which will occur in your model. You can also animate it by right click and then select animate. So this is the animation speed. You can reduce it. So this is the maximum displacement. Now another thing which is very important is that is this model strong enough to bear the load of 80 kg man or not? So we can do, or we can solve this issue by calculating the factor of safety. So for that, right click on the results and then go to define factor of safety plot, and then from here select all, click on next, multiplication factor 1, next, and factor of safety distribution, and then press OK button. So here is the minimum factor of safety, which is 5.2, and it means that this model is okay to manufacture because the factor of safety must be above 1. So now let's try another simulation by increasing the force to 4 times. So for that, right click on the force here and then edit definition, scroll down, and here on the value of the force, star for multiply by 4. So and then let's see. So this is the 3136 Newton force now. So now once again we are going to run this study to see what happens if we increase the force. Now first of all, let's see what is the factor of safety, and it is 1.3, and the displacement, this is the maximum displacement in our model. You can see. So by watching this factor of safety, which is 1.3, which means that still this model is okay to manufacture. And now once again multiply that factor of safety, instead of 4, this time let's say multiply by 2 and see what happens. Once again run this study. So this is the maximum displacement, animate, and then the factor of safety. So if you can see, 0.65 is now minimum factor of safety, which means that the model will break when we put that force on this model. So this is how you can do the SolidWorks simulation on the Weldments model. So I hope you have enjoyed and learned from this video. Thanks for watching and sparing time, and don't forget to subscribe this YouTube channel for more videos like this.